Next, we're going to focus on the analytical aspect of spatial thinking, particularly emphasize the spatial analysis method that we can apply to spatial data. Spatial analysis normally start with a question that you want to answer. The question may ask about the patterns of particular geographic feature in the space, or about a relationship among things. Okay, so this kind of question will dictate what kind of data that you're going to need for analysis and what kind of methods you're going to use for processing and for presenting data. Normally, we think about the spatial analysis as a 5-step process. First, you frame your question, and you should do this as specific as you can. And next, you're going to choose the data from among the available sources. Okay, this is very critical. Like we talk about the relevance of data, and the judgment on what data relevant is a critical aspect of spatial analysis. So you should know that to get from data to your answering question, you may have multiple methods you want to choose from. Choose one over the other may have implications on the cost, on the time, and on the reliability of your answer. Okay? And then you should implement the process and actually provide a way to present and help interpreting the results. In the first step, we talk about framing the question to guide analysis. And we'll start with formulating a few questions that are as concrete as possible. For example, you could have a question say, where were the most burglaries last month? Okay? Or how much forest we can actually in certain watersheds. Okay? So these are the questions that usually touch on both the matters as well as the location. The idea is that to analyze those questions and derive information need that help us to guide the data collection. When it comes to selecting data, there's a number of issues we may face. First, when you try to find data sources, there must be some other people have tried to answer similar questions, or they may already have collected data. You should try to find any existing data sets that can be directly used for your purpose, or a little bit of adaptation to that. Sometimes you find more than one kind of data there available from different sources. Then you're facing the decision that which one you choose from. One thing that I will remind you is that all the second-hand data, they were collected and compiled for different purpose. So you should be sensitive on analyzing and making a judgment of which one actually is closest to the question that you try to answer, and start from there. You should try to avoid collecting data from the beginning if you can, but that involves a knowledge about the data sets. Okay? So the quality and the reliability and the trustness of the data source come to play in this case. If you have the analytical methods in your mind, you should be able to decide some of the data sets just fit that purpose. For example, if you decide to use a geographic information system to look at the crime pattern, and you might go in sources that already have GIS data sets, for example, shapefiles or geodatabase that are already compiled and ready to use. That kind of data not exist, you may go a little backward to look for secondary data. As long as you know the kind of question you want to answer, the data source you have available, the next step is to choose a method to transform the data to answers to the question. The chances is that you may have many different ways of processing the data or analyze the data depending on the question you want to address. And sometimes the cost of analysis will be very different, or sometimes the result different. Okay, so deciding on the analytical methods are based on both the available data as well as the question you want to answer. For example, if you want to look for patterns of assault crime in a city, that question can be answered in multiple ways. So in the slides, I show three possible strategies. The strategy one, we can actually show the individual crime incidents as a map that show clusters of different crimes. Okay, and strategy two, actually, we can show the densities. Okay, the density of crimes over a regular grid. Okay, that gives you an idea of the distribution. Okay, the third strategy, maybe we want to kind of show an aggregate count of crimes over aerial units, for example, zip code or census block. So they actually have very different utility, and they have very different usage in terms of answering questions. Okay, for example, the incidence map may give you approximate ideas of distribution, but it doesn't really bring up the question of the density. Okay, so some of the points are kind of very crowded, and you can't tell. The strategy 3 actually is good at answering crime pattern that help you to compare one region from another, but is relatively less effective if you want to see more kind of in general space. So the strategy 2 might be better to see what is a reasonable distribution of crime. After the method of analysis is chosen, you have to implement that method by dividing it into a number of processes and tasks. And that depends on what makes sense to achieve your analytical goal. For example, if you want to map where things are, the first challenge is to assign the features to coordinates. We may have to assign categories. If you want to map numerical data, you may have to choose a way to break the numerical values into classes and represent them as a map. If you need to aggregate or to combine or relate information from multiple sources or multiple themes, then you may have to do some map overlay, query analysis. Those will be the likely process you're going to need. The last step of analysis will involve a decision on how to present information you have compiled to some form, either as charts, as maps, or as diagrams, as scatter plots, etc., that can convey the information for the purpose of making decisions or pick up patterns. Okay? So the kind of interpretation you're analyzing the clusters and hotspots, outliers, or you compare one place from the other, or you may want to analyze the association between one type of phenomenon to another. So all this kind of analysis require very different way to combine or present information. Carrying out spatial analysis tasks actually require quite amount of knowledge about the tools and the procedures and process to use those tools for analytical purpose. So we're going to spend about half of this class learning about the use of geovisual analytic tools for doing a number of categories of tasks. Okay, this is one of the reasons we have chosen the second textbook called the GIS Analysis. Book actually cover probably 6 categories of analysis, and they have very detailed guide on how those analyses work and also relate to geographic information technology.